presume everybody here has heard of IoT. Yes. What about low power wide area networks? Anybody? Okay, 1, 2, 3. Okay, a few. So this is a networking technology that came about a few years ago, and it was to be a catalyst for the IoT. So IoT, massive scale of devices, machine to machine. Low power wide area, that's the umbrella technology. Underneath you've got a few flavors that you may have heard of. Sigfox, LoRa, NB-IoT. Okay, so this is to be in any industry you can think of. Agriculture, industry, construction, and mining. In 2015, we got a grant from the Irish government to create an IoT testbed across the whole country. So we rolled out a LoRa network. And this was a testbed for city councils, startups, academics to come and see what IoT was about and what can these new technologies do. About 2 years later, when you get a large grant from the government, they tap you on the shoulder and say, now you have to create some jobs and start a company. So to use these LoRa networks in a commercial way, it was important for us to find certain industries where these are relevant. So again, low power. So I'm talking about a device that can be deployed in the field for 5 years, that can talk to a gateway that's 10 kilometers away. So it's a different type of networking technology when you think of cellular, 3G, 4G, or broadband, or Wi-Fi. Okay, so if we just keep that in our head. So some things you can do, you can go to a factory, you can measure temperature, you can measure liquid levels, you can measure movement, vibration of machines. Some of these use cases have come up already. However, there are overlay services which you can provide using these networks. And one of these I'm going to talk to you about today and why it's relevant for mining. So the main value enhancing overlay service is around geolocation. So cellular tried to do this about 20 years ago and used triangulation to get some positioning information based on mobile phones moving around. You'll have 3 masts which will do some mathematical algorithms and find out the location. This was using signal strength. On LoRa networks, you can measure the time of flight from a sensor that's moving around using 3 gateways and give you an accurate location. Why would you do this if you have GPS? So again, we're talking about the low power and wide area. If we think of a GPS module, we think of some power requirements and frequent recharging of devices, and also the cost in actually having a GPS receiver in your device. If you think about using a separate network to GPS for localization, this means all you need is a radio that can talk to your 3 gateways, and you can also get this information. So this can be used for lots of things in the mining industry. I hope you can see that. These are the ones that we've uncovered through our with EIT. And initially this will be rolled out in open pit mines. So we will use the higher frequency LoRa network, so about 2.4 gigahertz. We're going to have devices moving around an open pit mine, a vehicle, a person, an asset, and to get accuracies of about 2 meters, we'll have about 3 or 4 gateways across the open pit mine. So these are lightweight networks. If you were to put a cellular phone mast from scratch in a mine, it will cost you about €100,000. These networks are lightweight, so a gateway might cost you about 500 or €1,000. The trade-off here is this is for sensor networks, so it's not for image or audio or video. These are for devices that will send a really small bit of information, not that frequently. So a temperature, or a latitude and longitude, or a vibration status, okay? So if we look at an open pit mine, what the solution could be. So we talked about low power, now we talk about wide area. So if you think of a gateway typically for cellular or Wi-Fi or Bluetooth, you're talking maybe the hundreds of meters. This is over kilometers, so 2 to 5 kilometers. So look at a mine here, an open pit mine, it might be 3 kilometers by 1. You will use gateways at each corner, 3 or 4 gateways, and it will cover the entire area. Single meter accuracies are achievable with the higher frequency LoRa, so 2.4 gigahertz down to about 2 meters. LoRa also operates at the 868 megahertz frequency. This is more common, but the accuracies are about 20 to 30 meters. So in some cases this is okay. For collision detection and so on in mining, very high resolution accuracies are required. If you think about Bluetooth, it's used a lot now indoor in processing plants for localization. A lot of anchors are needed, okay? So every 50, 60 meters you'll have an anchor, and this is pinging to your device all the time to get to location. The idea here is to have much fewer anchors. So you've got lower cost, lower maintenance, lower power. So the end users then, typically it will be mining intelligence companies. We are systems integrators, so we don't have a data analytics platform. We don't know a lot about the mining industry. We're from a telecoms background, but we can provide the network and the hardware to bring this location data to mining intelligence companies, who will then provide it on to mining companies. So just a little bit more about the solution. So yeah, so typically if we think about collision detection, or possibly where GPS isn't very accurate or very robust in these scenarios, this is where gateways, which are also low power, can be rolled out. So very remote rural areas. You don't need any backhaul using cellular or Wi-Fi until you get to down into the hub of the mine. The principle here, it's the same as RSSI. So you'll have overlapping areas where the time of flight will be measured, and here you can use your solver to find out the location of your device. We're currently at TRL 4. We have funding from EIT to bring this through for the rest of the year with a couple of industry partners as well. This is to bring us back to the overall IoT theme. So it's supposed to, you see these graphs all the time. It's supposed to go like this, and this is for lots of different types of networks. Wi-Fi, Bluetooth, 5G, 4G. Low power wide area is the one that we're interested in. Again, this is the lightweight network where you can send a few numbers every few minutes. So it's not for everything. It's not for mission critical. It may be this over-the-top service that you get. But you can see that there will be an increase in these technologies. So if we look at the different ones here, there's lots of positioning technologies. Ultra-wideband, there's a very good talk here earlier on from Boliden. This is narrowband. So low power wide area works over the narrowband. These are the accuracies, close to GPS, and the point here is the power, right? So we're talking about something that will wake up and it will send a message with the battery, and the chirp spread spectrum that is used for LoRa means that it can last for a very long time. So, in summary, there is an appetite for location technology in lots of industries. However, if you're in a remote area, in a wide open space like an open pit or a processing plant where you can bring a dedicated network for a low cost, you can provide extra value with your location, with a location solution like ours. Thank you. Okay.